This is an audio-visual presentation on fraction. Now, when we are considering fractions, we will look at the types of fraction. A, we have common fractions. B, we have decimal fractions. Example 0.5, 0.75, etc. C, we also have percentages. Example 50%, 70%, etc. So these are the types of fraction we are going to consider: the common fractions, the decimal fractions, and the percentages. Now, with the common fractions, we also have types. We have the proper fraction. B, we have the improper fraction. C, we also have the mixed fraction. Now, let's consider these types of fraction one after the other, starting from proper fraction. So, proper fraction. Now, if R equals B over A, we can see that B over A is a fraction. For every given fraction, the number or the variable above the division sign is called the numerator, and the number or the variable below is called the denominator. Now, for a fraction to be a proper fraction, the numerator must be less than the denominator. That is why B is less than A. That is for R equals B over A to be a proper fraction. It means that B must be less than A, where B is the numerator and A is the denominator. So a proper fraction is when the numerator is less than the denominator. Example, 2 over 5 is a proper fraction because the numerator 2 is less than the denominator 5. 1 over 3 is also a proper fraction because the numerator 1 is less than the denominator 3. 3 over 7 is also a proper fraction because the numerator 3 is less than the denominator 7. So these are all examples of proper fractions. Now we have the improper fraction. Given R equals B over A, B over A is a fraction. For B over A to be an improper fraction, it means that the numerator B must be greater than the denominator A. So improper fraction is a fraction in which the numerator is greater than the denominator. Now when we consider this example, 13 over 5 is an improper fraction because the numerator 13 is greater than the denominator 5. 5 over 2 is also an improper fraction because the numerator 5 is greater than the denominator 2. 9 over 7 is also an improper fraction because the numerator 9 is greater than the denominator 7. So these are all examples of an improper fraction. So a fraction is said to be an improper if the numerator is greater than the denominator. Now we consider mixed fraction. In general, R equals A whole number B over A. So A whole number B over A is a mixed fraction. A whole number B over A is a mixed fraction. And a mixed fraction is a fraction that contains the whole number and the fraction. The whole number and the fraction. And these are all examples. We have 2 whole number 2 over 5. 4 whole number 1 over 3. 5 whole number 3 over 7, etc. These are all examples of mixed fraction. It contains the whole number and the fraction. The whole number and the fraction. The whole number and the fraction, etc. Now let's look at how we can convert mixed fraction into improper fraction. Now, given R, that is the mixed fraction, to be equal to A whole number B over C. A is the whole number. B is the numerator of the fraction. C is the denominator of the fraction. So if you want to convert the mixed fraction into improper fraction, we multiply the denominator of the fraction by the whole number. That is C times A. And that is how come we have C times A in bracket. Plus, then we add the results to the numerator. That is B. And that is how come we have plus B. All divided by the denominator of the fraction. That is C. So R is equal to C times A plus b divided by c. That is the denominator of the fraction times the whole number plus the numerator, all divided by the denominator. So that is how we convert mixed fraction to improper. Now let's look at this example. Given 3 whole number 2 over 3, converting this to improper, we multiply the denominator 3 by the whole number. That is 3 times 3, and that is how come we have 3 times 3 in bracket. Plus the numerator is 2, so we have plus 2. All divided by the denominator of the fraction, that is 3. Now 3 times 3, 3 times 3 is equal to 9, and 9 plus 2 is 11. So we have 11 divided by 3. 11 divided by 3. It means that the mixed fraction 3 whole number 2 over 3 is equal to 11 divided by 3, where 11 over 3 is an improper fraction because the numerator 11 is greater than the denominator 3. So that is how we convert mixed fraction to improper. We multiply the denominator of the fraction by the whole number. Then we add the results to the numerator of the fraction. Then we divide everything by the denominator of the fraction. That is how we convert mixed fraction to improper fraction. Now we have addition of fractions. We have addition of fraction. When we are adding fractions together, we have to find the LCM. That's the least common multiple. Now, given the fraction 3 over 4, we are adding 3 over 4 to 7 over 8 to 1 over 2. That is 3 over 4 plus 7 over 8 plus 1 over 2. Now, with addition of fractions, we have to find the LCM. Now, when we consider the denominators, we have 4, 8, and 2. When we consider the number 4, the multiples are, we have 4, 8, 12 in that order. Now the multiples of 8, we have 8, 16, 24 in that order. That is additions of 8 if you want to generate the multiples. Now the multiples of 2 are 2, 4, 6, 8, also in that order. Now we can see, considering the 3 multiples, that the least of the common multiples is 8. So we can find 8 here, 8 here, and 8 here. So the least of the common multiples is 8. And therefore, we find the LCM, and the LCM is 8. Now, we start. 4 goes into 8 2 times. So we multiply the 2 by the numerator 3, and that will give us 6. Plus 8 goes into 8 once. So we multiply the 1 by the numerator 7, and that will give us 7. Plus 2 goes into 8 4 times. So we multiply the 4 by the numerator 1, and that will give us 4. Now 6 plus 7 equals 13, and 13 plus 4 is equal to 17. So we have 17 divided by 8. That is 17 divided by 8. This means that 3 over 4 plus 7 over 8 plus 2 plus 1 over 2 is equal to 17 over 8. Is equal to 17 over 8. So take note, for addition of fractions, you have to find the LCM. Now let's proceed. Subtraction of fractions. We have 3 over 4 minus 1 over 3 plus 1 over 2. This we have subtraction and addition. Now it goes the same way. We have to find the LCM. So the LCM of 4, 3, and 2 is 12. Now 4 goes into 12 3 times. Then we multiply the 3 by the numerator 3, and the result is 9. Now we have our minus here. 3 goes into 12 4 times. So we multiply the 4 by the numerator 1, and that will give us 4. Plus, because of our sign. 2 goes into 12 6 times. So we multiply the 6 by the numerator 1, and that will give us 6. Now 9 minus 4 equals 5, and 5 plus 6 equals 11. So we have 11 divided by 12. This means that 3 over 4 minus 1 over 3 plus 1 over 2 is equal to 11 over 4. Is equal to 11 over 4. So that is how subtraction of fraction also goes. Now multiplication of fractions. Example, Giving 2 over 3 times 4 over 3. 2 over 3 is a fraction, and 4 over 3 is also a fraction. Now, if you are multiplying 2 over 3 by 4 over 3, with multiplication of fractions, please don't find the LCM because we don't find LCM. With multiplication of fractions, we multiply the numerators divided by the multiplication of the denominators. That is all. So 2 over 3 times 4 over 3 is equal to 2 times 4. That is 2 times 4, all divided by 3 times 3. So 2 over 3 times 4 over 3 is equal to 2 times 4, all divided by 3 times 3. Now 2 times 4 is equal to 8, and 3 times 3 is equal to 9. This means that 2 over 3 times 4 over 3 is equal to 8 over 9. So that is how we multiply fractions. We multiply the numerators divided by the multiplication of the denominators. That is all. Take note, please. For multiplication of fractions, don't find the LCM. For multiplication of fractions, don't find the LCM. Multiply the numerators divided by the multiplication of the denominators. That is all. Now let's proceed. Division of fractions. Division of fractions. Now example, if you are given 2 over 3 divided by 4 over 3, our concentration is on the fraction after the division sign. So 2 over 3 divided by 4 over 3 is equal to 2 over 3. That's the fraction before the division sign remains the same. With division of fractions, the division sign changes to multiplication as shown. I repeat, with the division of fractions, when you are simplifying, the division sign quickly changes to multiplication. And as soon as you change the division sign to multiplication, take note that with this fraction, the denominator now becomes the numerator, and the numerator now becomes the denominator. So instead of 4 over 3 is now 3 over 4. Why? Because the division sign has been changed to multiplication sign. It's very important. Please, we consider the fraction after the division sign. The denominator becomes the numerator, and the numerator becomes the denominator as soon as you change the division sign to multiplication. This means that 2 over 3 divided by 4 over 3 is equal to 2 over 3 times 3 over 4. Instead of 4 over 3, it's 3 over 4 because we have changed the division sign to multiplication. Now we are back to multiplication of fractions. So how do we multiply fractions? We multiply the numerator, so 2 times 3, divided by, we also multiply the denominators, so 3 times 4. Now 2 times 3 divided by 3 times 4. When you multiply 2 by 3, the answer is 6. And when you multiply 3 by 4, the answer is 12. So 6 divided by 12 is equal to 1 over 2. That is 6 goes into 6 once, and 6 goes into 12 2 times. So 6 over 12 can be simplified as 1 over 2. Example, simplify the following. A, 3 whole number 3 over 4 plus 2 whole number 2 over 3. B, 1 whole number 5 over 6 minus 1 whole number 3 over 8. Let's see how best we can simplify this problem. Solution. A, 3 whole number 3 over 4 plus 2 whole number 2 over 3. We first convert the mixed fraction to improper, and now we know how to convert mixed fraction to improper. So we multiply 4 by 3, and the answer is 12. Then 12 plus 3 equals 15. So it's 15 divided by 4. That is how come we have 15 divided by 4. Plus 3 times 2 equals 6. And 6 plus 2 equals 8. So we have 8 divided by the denominator 3. So we have 8 over 3. Now we have 15 over 4 plus 8 over 3. And this is addition of fractions. Now with addition of fraction, you know that we find the LCM. And so the LCM of 4 and 3 is 12. Now 4 goes into 12 3 times. And when we multiply the 3 by 15, it's equal to 45. Plus 3 goes into 12 4 times. And 4 times 8 is equal to 32. Now 45 plus 32 is equal to 77. Divided by 12. So we have 77 divided by 12. Now 12 goes into 77 6 times, and the remainder is 5 over 12. That is the mixed fraction of 77 over 12. You can leave your answer either as 77 over 12 or 6 whole number 5 over 12. Now let's look at the example in B. Given 1 whole number 5 over 6 minus 1 whole number 3 over 8, we also convert all the mixed fraction to improper. Now 6 times 1 is 6, and 6 plus 5 equals 11. So we have 11 over 6 minus 8 times 1 equals 8, and 8 plus 3 is equal to 11. So we have 11 divided by the denominator, that is 8. Now 11 over 6 minus 11 over 8. We have to find the LCM, and the LCM of 6 and 8 is 24. 6 goes into 24 4 times. 4 times the numerator 11 is 44. Minus 8 goes into 24 3 times, and 3 times the numerator 11 is 33. Now 44 minus 33 is equal to 11. So we have 11 divided by 24. So we have 11 divided by 24. This is our answer. Now order of operations. Order of operation. We have what we call the board mass. That is BODMAS. B is the bracket. O is off. That's multiplication. D is the division. That is division. M is multiplication. A is addition, and S is subtraction. So we have what we call the board mass. That means that if you are given any expression, first solve the bracket first before off, and the off is the same as multiplication. Take note. Then you go to D, that's division, before you go to multiplication itself, before you tackle addition, and finally subtraction. So this is the order in which you have to simplify an expression in terms of fractions. Board mass. B is bracket, O is off, D is the division, M is multiplication, A is addition, and S is subtraction. Now example. Simplify the following. 1 whole number 2 over 3 minus, we have 1 whole number 3 over 4 divided by 2 whole number 5 over 8. B, 2 whole number 1 over 3 plus 4 whole number 1 over 2 in bracket, all divided by 8 whole number 1 over 5. So we are going to use the principle of the board mass. That is BODMAS. Bracket first, off, division, multiplication, addition, and subtraction. That means that with the example in A, first we have to solve the bracket first. There is no off. So solving the bracket, we jump to division before multiplication, addition, and subtraction. Now let's see how best we can solve this problem with the idea of the board mass. Now solution. Given 1 whole number 2 over 3 minus 1 whole number 3 over 4 divided by 2 whole number 5 over 8. So the bracket first. So quickly we have to change our mixed fraction to improper. So 4 times 1 is 4. 4 plus 3 is 7. So we have 7 over 4. Divided by 8 times 2 is 16. And 16 plus 5 is 21. So we have 21 over 8. So now you also look outside the bracket. We have 1 whole number 2 over 3. It's a mixed fraction. So we also convert. 3 times 1 is 3. And 3 plus 2 is 5. So you have 5 over 3. But the 5 over 3 remains the same because you are still solving the bracket. Now we have 7 over 4 divided by 21 over 8. Now a step down, 5 over 3 remains the same, minus, we are still solving the bracket. 7 over 4, the fraction before the division sign remains the same. But the fraction after the division sign is not going to change because the division sign is to be changed to multiplication. So the 8 goes up and the 21 comes down. That's the denominator becomes the numerator, and the numerator becomes the denominator. So instead of 21 over 8, we have 8 over 21. So 7 over 4 divided by 21 over 8 is now equal to 7 over 4 times 8 over 21. Now 4 goes into 4 once, that's why we have 1 here. And 4 goes into 8 2 times, that's why we have 2 here. Also 7 goes into 7 once, that's why we have 1 here. And 7 goes into 21 3 times, that's why we have 3 here. So we have 5 over 3 minus, in bracket we have 1 over 1 times 2 over 3. We are not done with the bracket, so we still have to continue. Now let's proceed. So 5 over 3 minus 2 over 3. That is when you simplify the expression in the bracket. Let's go back. 1 times 2 equals 2. And 1 times 3 equals 3. So this is equal to 2 over 3 in bracket. And that is how come we have 2 over 3 in the bracket. So we now have 5 over 3 minus 2 over 3. Now we open the bracket. So we have 5 over 3 minus 2 over 3. 5 over 3 minus 2 over 3. Now we go to subtraction, because there is no division now, there is no multiplication now, there is no addition now. So we now go to the subtraction. So 5 over 3 minus 2 over 3. With subtraction of fraction, we find LCM, and the LCM is 3. 3 goes into 3 once, and 1 times 5 equals 5. Minus 3 goes into 3 once. 1 times 2 equals 2. Now 5 minus 2 is equal to 3. So we have 3 divided by 3. And 3 divided by 3 is equal to 1. 3 divided by 3 is equal to 1. That means that our final answer is equal to 1. Now let's look at the example in B. 2 whole number 1 over 3 plus 4 whole number 1 over 2 divided by 8 whole number 1 over 5. Now let's solve the bracket. So we convert all the mixed to improper. 3 times 2 is 6. And 6 plus 1 equals 7. So we have 7 over 3. Plus 2 times 4 is 8. And 8 plus 1 is 9. So we have 9 over 2. Divided by, now we also convert this mixed fraction while solving the bracket. So 5 times 8 is 40. And 40 plus 1 is 41. So we have 41 divided by 5. Now in the bracket we have 7 over 3 plus 9 over 2. It's addition of fraction. With addition we find LCM. And the LCM of 3 and 2 is 6. 3 goes into 6 2 times. And 2 times 7 is 14. Plus 2 goes into 6 3 times. 3 times 9 equals 27. So we have 14 plus 27 divided by 6 times 5 over 41. Now when we add 14 to 27, the result is 41. So we have 41 over 6 times 5 over 41. That is 14 plus 27 is equal to 41. So we have 41 over 6 times 5 over 41. Now this is multiplication of fraction. So we can multiply the numerators divided by the multiplication of the denominators. Or because 41 can cancel 41 as shown, we can cancel the 41 out and we are left with 5 over 6. So the final answer is equal to 5 over 6. That is 5 divided by 6. After the 41 has cancelled, we are left with 5 over 6. This is the end of our presentation on fractions.